Hello and welcome. My name is Leonid and I'm a researcher and lecturer at the University of Applied Sciences in Berlin, and I specialize in the development of mixed, augmented and virtual reality applications. In this video, I will show you how to develop a basic augmented reality application with Vuforia. But what is Vuforia and what is it used for? Vuforia is a library for augmented reality functionalities, which include things like image tracking or object tracking. Also, Vuforia is multi-platform. This means that you can build your application, for instance, to Android or to iOS devices, but you don't need to, because you can test your application inside of your Unity editor. And the last cool thing is you don't need to know how to program to build an augmented reality application with Vuforia. So let's have a look what we will learn in this video. We will be starting by creating a Vuforia account. Then we will create a license to be able to use our account. And in the last step, we will create a marker database for our image targets. In the next step, we will open our Unity editor and we will install Vuforia, we will activate Vuforia, and in the next steps we will create an augmented reality camera, our first image target, our first augmentation on this image target, and in the last step we will test our application. And as a little bonus, we will also implement a little custom behavior with some code. So let's jump inside our Vuforia and have a look how to do this. First of all, I would like you to open your internet browser, go to Google or your favorite search engine and write in Vuforia developer and visit the first website that appears. Here I would like to create an account, so I go in the top to register. And then you are asked for things like your first and last name at your company, especially for creating as a student privately a project. This is not so important to type in your real information. So in my case, I am Leonid, but my full last name is not so important here. And also my company could just be something like me or cool company and so on. So it's not so important that you really have a job or a company in this case. And in my case, I'm sitting in not in Gabon, I'm sitting in Germany. Someday I will find this. Here we go. And so on. So just create a Vuforia account. It's not so important that you have all the information like a company. And when you have created a Vuforia account and you have logged in, you will find yourself under developer.vuforia.com under the tab Develop. And here I would go to the license manager to create a new license for our coming application. As you see on my account, I have already a lot of licenses. I will go to Get Basic license, Get Basic. This license I will give a name, something like tutorial. Today is the 24/01/13th. And I will check this box. So I have read the developer agreement and I go to confirm. Here we go with our new license. I can click on it and then you will be able to see what we can do with this license. So this is a basic license. We have license codes that we later on can copy. This license will not expire. And very important in this case, this has changed over the last years. You can use this license even to not only implement your application, but also publish it. Some years ago with Vuforia, you had to buy a premium license to be able to publish your application in the App or Play Store. This has changed, which is very cool. In the next step, we will create a marker database. But first of all, I would like to talk with you about the characteristics for good markers. A marker you can imagine like an image that you have printed out, like a picture of the Mona Lisa, or a selfie from you, or just a simple picture of a leaf. but not every picture is a good marker. Here in my slides, you see that a good marker is rich of contrast, so it has a lot of edges, so the algorithm is able to detect the differences in the image. What is not good is having a marker or image with organic shapes, something round, something with reflections, like in the second picture here. This is not a good marker, it will not be recognized. On the other hand, colors are not important. So either you have a black and white picture or you have a colored picture, this makes no difference. So you have just to take care that you have a lot of contrast and not so much organic shapes. And the last thing which is important is that you have no repetitive patterns like on this playing card, because in this case the algorithm will not know where is the top, where is the down. So when you're creating markers or you're selecting images, take care of this. But in the next step, I will show you how the Vuforia database can say to you what is a good marker and what is not. We will return to the Vuforia website. Here we go to the target manager at the top. And here we will click on Add Database. We give the database a name, in my case again tutorial, the date, in my case. In your case, it could be the name of your application, something like best AR game ever. And what I will choose today is the device type, what is also interesting is a cloud type where you can kind of stream your markers from the internet. For today's example, device is sufficient. So we go on create. And as you see, I have again a lot of databases already. I will search for tutorial. And here we go. I click on our new database, and our next step is to click on Add Target. Here you have a lot of options. For instance, you can select a multi-target. This one you can imagine like a packaging for milk, where you can print on each side something different and show on each side something different. Similar to this, you can choose a cylinder, which is like a cola can that you can use as a marker. And the last thing, which is deprecated now, is object tracking. So please don't use this one. It's not supported anymore. Today we will stick with the image, with the simple one. We will choose a file. I'll click on Browse, and I have prepared already 3 images. These are standard examples from Vuforia. We will start with tarmac here. As you can see, the name for the marker was already auto-filled. And of course you can change this name, which is important that you choose a name that you can recognize later on. The next thing that we have to decide is the width. And the width is the size of the image that it will have in the real life. So when you type in something like 10 meters, you need to print out an image that is 10 meters in the width. Actually, it would still work. Imagine you have an image which is, let's say, 20 centimeters in the width, and you type in it's actually 10 meters. It will work, but then your application will think that your marker is, how much is this? That it is 50 meters away from you, which will break features like special audio that you have in your application. So in this case, please stick with the width that your image will have in the real life. I will stick, for instance, with 20 centimeters, so 0.2, and I will go to Add to create this one image target. As you can see, it was created and it has a rating, which is very cool. So we can click on the created image target, and we can click here down to show features. And as you can see, there are a lot of feature points, so contrasts that were found, which are important for the algorithm to recognize this image. That's why it has 5 stars. And this is because this is a marker that Vuforia provides, which is good recognizable. I have also prepared a PDF from Vuforia, which I will link to you, so you can print out these markers to test your application. So let us return to our new database and add the other images. So I go again to add target. I will browse for the stones here. I will give it a width. You can also stick with smaller numbers like 0.1.5 or 50 centimeters, for instance. It will also get 5 stars. And I will also add the last image, which are the chips. And just for the example, so you can later on see it in the Unity editor, I will say this one is 1 meter in the width. And later on you will see there is a difference. What I would also recommend is that when you have 5 stars, this is perfectly fine. 3 stars are maybe also okay-ish, but everything with 1 or 2 stars is not a good marker. Please don't use this one. So now we have all of our images uploaded. I will refresh my website here. All of them have 5 stars. And the last steps that we need to do is to download this database. So I will go to download database all. I will say I'm working with the Unity editor. Actually, it's also possible to program with Vuforia outside of a game engine. Today we will stick with Unity. I will click on download. And we have downloaded our Unity package. And in the last step before we jump to the Unity editor, I would like you to go on the top of the Vuforia engine portal, go to downloads. This can happen that it's buggy, so we go again on downloads and we need to download the Vuforia engine for our Unity project. Here you can select a version. We will stick with the newest version and I will click to add Vuforia engine to a Unity project. And as you can see, it will be downloaded now. And so we are now prepared to work inside of our Unity editor. To repeat this, we have now a license key. We have now the SDK for Vuforia, so development kit, and we have also a database. So we have everything together to implement a Vuforia augmented application. Let's start with this. Let's continue with Unity. I have already opened the Unity Hub. As you can see, I have a lot of projects already. For this tutorial, we will create a new project. Here you can select from different templates. I will stick with the 3D template. I will give my project a name, like Vuforia tutorial in my case. I will select a location. For me, it's my Unity projects folder. And what you need to do is select an organization, like this one for me. For an organization, you actually need to create a Unity account, but this is not part of this tutorial. What I also don't need is connecting to the Unity Cloud. This is a new feature, and I also don't need the version control of Unity. And after all this, I can also select the Unity version. I have some of them installed on my computer. What I would recommend for you is to have at least a version from 2021 or 2022 is also good. And I also recommend sticking with a LTS, or long-term support version, which is kind of a version that is quite stable. I will stick with 2022.3.9, which is an LTS version, and I will click on Create Project. Creating a new Unity project can take a few minutes. Here we go with a new project on my side. We have an empty Unity scene, which is called sample scene. We have a scenes folder. And the next step that we would like to do is to import our Unity Vuforia packages. So I will go up to Assets. I will say Import Package, Custom Package. And I will select For my downloads, first of all, my add Vuforia package to install Vuforia to my Unity project. Then you get a new window with import Unity package, select everything and say import on the downside. This can also take some minutes. When you get here a new window with add Vuforia engine package, you will click on update. After you have imported Vuforia, in the next step we will also import the database that we have created. So I will go again on assets, I will go to import package, custom package, and I will select my tutorial database. Also here you have to select everything, and then I will click again on import. When this is done, we will go to our scene. We have here sample scene. We can also create a new scene, which I will go on create, I will go on scene, and the scene I will call Vuforia AR tutorial, for instance. I will double click on the new scene, and this looks like the same as the previous scene. Our first step will be deleting the default main camera, because we need now an augmented reality camera. To create the AR camera, we will do a right click on our hierarchy, and we will say Vuforia engine, and we will select the AR camera. In this case, we also need to accept the license. And here we go with our new augmented reality camera, which is not finished yet because the AR camera has a lot of settings that are interesting for us. For this one, we will select the camera in the hierarchy. We will go to the inspector on the right side, and we will scroll down to the Vuforia behavior component and select the Open Vuforia Engine configuration. The first thing that we need in the configuration is the license key that we created previously on the Vuforia portal website. For this one, we go back to our browser. We will go to Develop, to the License Manager. I will select my created license, and when it loads, and then by clicking on my license key, it will be copied to my clipboard, and I will return to Unity and paste the new license key inside. You don't need to click to add license, which also has disappeared now. And then we can have a look at the other settings that we have. For instance, we have here something like max simultaneous tracked images. This means that you can only recognize one image on the same time, which is perfectly fine. But imagine that you have an application where you would like to recognize two images. So when the two images are recognized at the same time, they make something like a fusion and create a new visual effect or something like this. You would need to increase this number to 2 or 3, for instance. What also is interesting for us is the play mode. Here you can say how you would like to test your application. Today we will start with the webcam for our test later on, but you can also work with the quite new simulator, which will allow you to test your application without a webcam, but this is a thing we will have a look later on. In the next step, we can also select a camera device for webcam. I have some of them. I will go with my actual webcam. DroidCam is also an interesting app that you can download on your smartphone, so you can use your smartphone as a webcam. I will stick with my webcam on the computer. And let me have a look what also is interesting for us. This is actually all for the beginning. So we have now created our AR camera and we have activated our license key. The next step, I would like to create our first image target. Here I go again to my hierarchy. I will do a right click. I will go to Vuforia engine again. And as you can see, we have a lot of options here. We can also create ground planes or mid-air or cylinder targets. as we created our database only with image targets, we will stick with them. So I will go to image target. And as you can see in the scene, an empty image target was created. We will click on this object and we will go back to the inspector here. And we have a lot of options to select our image target. Nowadays, actually, you can even drag and drop an image from your Unity project inside of this, so you don't need to create a database on the Vuforia website. But doing this, creating the database, has a lot of advantages, for instance, in testing in the editor and in the preview. So I recommend working not from image, but from database. And here I can select my database. I have only one in the project. And here I can also select an image target that interests me. I have three of them. I have the stones, I have the tarmac, and I have the chips. And that what I wanted to show you previously is that when I select the stones, which are, I think, 20 centimeters, as I said, you see that this one is smaller than the chips, which I select here, which are 1 meter in the size. And this is actually a difference later on when you build your application to your smartphone for things like the distance that is suspected for the image. Nevertheless, I have now created my first image target. I have now selected an image that interests me. And then the next step, I would like to add our first augmented reality content. We will start with a simple basic shape, like I will create on my image target object. I will do a right click. I will go to 3D object and I will select a cube. And as you can see, a cube was created as a child of the image target. And the default cube of Unity is 1 meter in the size, which is quite big for a 20 centimeter image target. So in this case, we need to scale down our cube. This we can do in the inspector, in the scale. I can say combine all of the scales, and I can say that the cube will be, let's say, 10 centimeters in the width, in the height, and in the depth. And so we have now our cube on the marker. I can move the cube a little bit on this marker, and let's say I will place it in the corner of this marker, which is important because you will later on see that the cube will always be on this corner of this marker when it's recognized in the application with the webcam. And this is actually all of the preparation. We have created our first content for our image target, for our marker. We can also go to the image target and have a look on the default observer event handler. Later on, we can add some events for this. This is not so important now. What is important for us now is consider target as visible if its status is. Here we can say, for instance, tracked, which means that the marker is only recognized when it's seen by the webcam, which is perfectly fine and often this thing that you would like to do. An interesting option is extended tracking, which allows us to have, for instance, a very big object or content or marker. So let's say we recognize the marker initially, but then you can with your smartphone go up and see the whole content. So with this case, when we say on our image target extended tracked, you can also use the marker just as an initial recognition. And what we can also do is extended tracked or limited, which is also, let's say, also the extended tracking, but even more extended. It's hard to explain. We will stick with the tracked one. So when the marker is recognized, we will see the content. When it's not recognized, we don't see it anymore. So we save our scene. We go to File, Save. And in the next step, we will test our application. To test our application, we just have now to click on the play button inside of Unity. And then the Vuforia application will connect with my webcam, as you can see here. Here's my hand. And now I can select an image and put it in front of the camera. And as you can see, the cube that we defined appears on the marker on the image target in the corner that we have defined, and it moves with the marker. And now when I remove the marker from the image, the cube also disappears. What we can also test is to take the same image, but you will see it's not recognized twice because this is not possible. You can either have this image or you can have this image. As you can also see, the color is not important, but you can always only have one of the same. Now we can stop the play mode by clicking again on the play button, and what we could try the next step is creating another image target by right-clicking in the hierarchy view, going to Vuforia engine image target, and this one I will call image target chips. This one I will rename to image target tarmac. And in the chips one I will select from database, tutorial and chips. This is a 10 meters marker actually, or was it 1 meter? It was 1 meter. And also here I would like to add a content. So I go again on my object from the image target. I will do a right click, I will say 3D object, and I will select, let's say, a capsule, which is quite huge. Our job now is to scale it down a little bit, maybe also to rotate it slightly. So I can also show you that the content always stays on the same position in the same rotation of the image target. Here we go. Now I save my scene with with file save. Then I will go to the play mode again and let's see what happens. So we start again with our previous marker with the tarmac. But now I can also take the chips marker and you see the capsule appears. And I even can have both of the markers on the same image and both of the contents are appearing. On this marker, on this image, you actually see this is not the whole image. I have cutted it a little bit, so it's squared now. But this is not so important for the image recognition because it just needs many of the found feature points, but not all of them. So I can have both of them, and as you can see, this is not so important in this case that I defined this one as being 1 meter in the width and this one as 20 centimeters, because I don't have features that depend on it. But when I would now having something like a video playing on this marker, it would think that it's a lot more far away and the video would be less loud than it would be sorry, when I define the size like it is in the real world. So let us stop the play mode again. And in the next step, I would like to show you how you can use the simulator. Imagine that you don't have a webcam or you're in a situation where you're not able to use your camera. Vuforia invented the simulator, so we go to the AR camera. We scroll down in the inspector to the Vuforia configuration again. And downside we have here again our play mode type. Instead of the webcam, I will use now the simulator. And the simulator is like a player in a video game, so you can control it with your keyboard keys like V, S, T, A, etc. And I will show you in the play mode. So we go on play again. And now I can look around with my camera. And I can fly around with the keyboard buttons. So when I click the right mouse button, I can look around and I can move around with my keyboard. And then I can found and I can lose the markers. That's all actually. So you can test Vuforia even without having a camera and also of course without building the application to your smartphone. You can, by the way, also go down with the Q button, or go up with the E button, depending on your keyboard layout, of course. In the next step, I would like to implement some advanced behavior with you. For this example, I prepared a video asset. So I go under Assets, I will go to Import New Asset, and I will select the random video that I found on my computer. This is now imported into my project. I can also create, with right click, create a new folder, which I will call Videos, for instance, and I will place it here, which is only important for a clean project. And in the next step, I would like to add this video to one of the markers. So I select, for instance, the tarmac marker. I delete the cube. And I will say on the tarmac marker, with right click, I have a 3D object, which is a plane. And here we go with the plane, which I will use as a video plane. As you can see, it's now a little big. And this is a video in the format of 16:9, I think. So my job is now to scale this plane so it fits on the marker and it has the resolution, the aspect ratio, I mean, that I would like to have. So I say on the x-axis I have 16, on the z-axis I have 9, which is good enough for the aspect ratio. And now I just want to scale down this plane to fit on my marker. Here we go. Oops. Okay. And now the plane is more or less on my marker. I will push it a little bit up. And now I go on this video plane object in the inspector, go down to add component. I will say I would like to have a video player. In this video player, I will add over drag and drop my imported video to the video clip. And I would like to say, don't play this on awake. And maybe we can say, play this video in a loop. This is okay. So far, so this. Now we have the problem. Imagine the marker is found and nothing will happen because now we have to implement this advanced behavior of playing a video when a marker is found, or stopping the video when a marker is lost. For this one, I have two ways for you. The first one is going to the image target object and to say here in the inspector on target found, I will say with the plus, I have an event that I would like to execute. Then I will drag and drop my video plane object. In no function, I will say the video player and I will say play. So simple. And on the target lost, I will also drag and drop the object and I will again send video player dot stop. So in this case, we can test it. When I find this image target, the video will play. When I lost it, it will stop. I will save my scene and I will go on play. I'm still in the simulator, so I don't need my webcam in this example. And as you see, when I go away, the video has stopped. And then it begins from the beginning. Whoop, whoop. So this one has worked. This is our first advanced behavior. But of course, I am a computer scientist and a programmer, and many of you are also. So I would like to code with you a little bit. First of all, I would like to open the default script from Vuforia for tracking. This might take a minute. Here we have the default script from Vuforia for managing the tracking of the image targets, the default observer event handler. It has the enum for tracked or extended tracked. This is for me not so important in this moment. What for me is interesting in this case is on tracking found and on tracking lost events that are called with the internal logic of Vuforia. And when this happens, this method is called, which is called set components enabled with the boolean true or false. What happens here is that all renderer components from the game object, so everything visual, is enabled or disabled. The same for the collider components, so other objects are not able to collide with, for instance, the car that you have on your image target anymore when it's not in a camera. And also all canvas components, so all user interface components, are also deactivated or activated when a marker is lost or found. This is the default logic from Vuforia. And what I would like to do now is to re-implement this script to add some custom logic for our image targets. For this one, we will return back to Unity. I will go to my assets. I will do a right click. I will create a new folder, which I will call scripts. And inside of my scripts folder, I will again do a right click, create, and say C# script. And I will call this custom trackable behavior, for instance. It's not important how you call this. It's just your custom logic. So this is my script now, and I would like to re-implement the default observer handler. I will open it side by side. And the first step I would like to do is just take this one and inherit from it. Inside of mono behavior, I will inherit from the default observer handler. And in my case, I would like then to override some of its methods. The interesting thing about Vuforia is that its implementation changes in every version of Vuforia. So for instance, the logic of onTracking found and onTracking lost with the set components enabled has changed over the last years again and again, and the names have been changing. So when you're watching this video not in 2024 but in 2030, it may be very different. Nevertheless, I would like to override the method on tracking found, and I would like to override the method on tracking lost. So what I do now with my script here is implementing the whole logic that the other script from Vuforia is already doing, and now I can implement here my custom logic for finding my marker, for instance. And as we were working with the video, I will do a reference to my video player in my script. So it's public video player. This one needs an import, I think. Yes, using Unity Engine.video. I say public video player video, for instance, is my variable. So in my Unity inspector, I can assign now this video. And now I can say video.play when the marker is found, and I can say video dot, let's stick not with stop, let's stick with pause when the marker is lost. We will save the script and return back to Unity. Our script is now compiling, and what we need to do now is to go to our image target, and I would like to delete the default observer event handler. So I go here to the three points. I will go to remove component, and I say now add component custom trackable behavior. This is ours, which inherits from the other default component. Here I can say I want to use the tracked behavior. I can still use the onTarget found and onTarget lost events in the inspector, but in our case we are doing our logic in our code. So the last thing I need to do is to reference our video in the variable that we defined. I will save my scene, and then we go on play again. Need to find our marker. Here is our other first marker. And as you can see, the video is behaving like it was behaving before. So when we found the marker, it plays. But now it should be playing from the position where it stopped when we lost the marker. And it does. And we stop now. So what we have done now is implementing our custom behavior for playing the video, so pausing the video, which is maybe not so interesting, but this opens for you the door to implement everything that you would like to do when the marker is found, like instantiating or spawning other objects, so do game logic like two characters who are speaking with each other, or giving the user or the player a task which differs from the last finding of the marker. So everything which is more advanced you can do in your code. And this is the basic code that you can write for starting with the custom behavior. And this was our Vuforia tutorial. What you have learned is creating a Vuforia account, creating a Vuforia license, and creating a marker database with simple image targets. You also learned how to install Vuforia inside of the Unity editor, creating an AR camera, activating the Vuforia license, creating image targets, add your first augmentation to your marker like this one here. You also have learned how to test your application just with your webcam or even without a webcam in the simulator. And the last step, you have also learned some advanced behavior like assigning events in the Unity inspector or even creating custom code for doing your game logic in augmented reality. This was my tutorial. Thank you for watching and enjoy implementing augmented reality. Bye bye.